In our previous session, we discussed importance of forecasting. Today, we are going to explore a very new topic, that is process of forecasting. Imagine you are managing a retail store and the sales peak during the festive season. To ensure sufficient stock and avoiding over ordering, you need to predict how much inventory is required. So what steps would you take to estimate future demand, and how would you categorize the methods involved in making these predictions? At the end of this topic, you will be able to outline process of forecasting. You'll also be able to classify forecasting processes. Now let's delve into the process of forecasting. The process of forecasting involves several critical steps that ensure accurate predictions and informed decision making. Here's a detailed explanation of each step. Set clear goals. The first step in the forecasting process is to establish clear objectives for what you aim to achieve. This could involve predicting sales for a new product or estimating staffing needs for a busy season. For example, a retail company might set a goal to forecast demand for holiday merchandise to optimize inventory levels. Gather information. Once the goals are defined, it's essential to collect relevant data that will inform the forecast. This data can include historical sales figures, market trends, and economic indicators. For instance, a restaurant might gather information on past customer traffic patterns during holidays to aid in forecasting future attendance. Choose a method. After gathering information, selecting the appropriate forecasting method is crucial. This can range from qualitative approaches like expert opinions to quantitative methods such as time series analysis or regression models. For example, a tech company might use a quantitative method like moving averages to forecast future sales based on historical data. Analyze the data. In this step, the gathered data is analyzed to identify patterns and trends that will aid in making accurate forecast. Techniques such as statistical analysis or data visualization can be employed to understand the relationships within the data. For example, a manufacturer may analyze production cost over several years to determine how they correlate with the sales volume. Make the forecast. Based on the analysis, the actual forecast is generated, providing the estimates for the future. This can involve projecting sales figures, inventory levels, or other critical metrics. For example, a clothing retailer may forecast that sales will increase by 20% in the upcoming spring season based on analysis of previous year's trends. Validate the forecast. Validating the forecast involves checking its accuracy against real-world outcomes. This could be done by comparing the forecasted values with the actual performance metrics over a specific period. For example, after the holiday season, a toy company might compare its sales forecast with the actual sales achieved to assess accuracy. Review and adjust. The final step is to review the forecasting process and make necessary adjustments based on validation, results, and changing conditions. This ensures that the future forecasts are improved and more aligned with the reality. For instance, if a company notices a consistent overestimation in its forecast, it may refine its methods or gather additional data to enhance accuracy in subsequent forecasting styles. By following these steps, organizations can develop a structured and effective approach to forecasting that enables them to make informed decisions and respond proactively to market demands. Let's take a closer look at a variable of interest. In the context of forecasting, the variable of interest is a crucial factor that significantly influences the predictions being made. While it is commonly assumed that the primary focus of forecasting is demand, typically linked to sales, this perspective can be broader. Forecasting can pertain to various outcomes resulting from natural processes or specific activities designed for particular purposes. For instance, one might forecast election results based on polling data and historical voting patterns, which is essential for political analysts and campaign strategists. Similarly, forecasting material requirements in manufacturing helps businesses ensure they have the necessary resources on hand to meet production demands, thereby optimizing inventory management. Weather forecasting is another example where the variable of interest can profoundly impact various sectors, including agriculture, transportation, and emergency management. By understanding the variable of interest in forecasting, organizations can make more informed decisions across diverse applications, enhancing their operational effectiveness and strategic planning. Now let's discuss how to enhance the accuracy of forecast. Several critical factors must be considered. Input elements involved. The accuracy of forecast heavily relies on the input elements or variables selected for analysis. Choosing relevant variables ensures that the forecast captures essential trend and influences. For instance, when forecasting sales for a new product, input elements might include market trends, consumer preferences, and economic indicators, which collectively provide a comprehensive view of potential demand. Availability of the data. The accessibility of the relevant data plays a pivotal role in accurate forecasting. Organizations must have timely access to historical and current data, enabling them to make informed predictions. For example, a retail company may use historical sales data to analyze seasonal trends and better prepare for upcoming sales periods. Accuracy of data. The precision of the data used in forecasting is paramount. Inaccurate data can lead to misguided forecast and poor decision making. For instance, if a manufacturer relies on flawed data about raw material costs, it may end up overestimating production expenses, which could lead to budget constraints or financial losses. Representativeness of data. The data must accurately represent the population or phenomenon being forecasted. If the data is biased or not reflective of actual conditions, the forecast may not be reliable. For example, if a company only analyzes sales data from one store location, the forecast may not accurately represent overall company performance across various markets. Process generating variable. Understanding the underlying processes that generate the data is crucial for accurate forecasting. Analyzing how different variables interact and influence outcomes helps in creating more robust models. For example, in predicting demand for a product, recognizing how promotional efforts and seasonal changes affect sales can improve forecast accuracy. Adequacy of data. Having a sufficient amount of data is essential for building reliable forecast. Inadequate data can lead to uncertainty and increased variability in predictions. For instance, a startup may struggle to forecast demand accurately if it lacks historical sales data or customer insights. Stability of process. The stability of the process underlying the forecast is critical. If the process is subject to frequent changes or disruptions, the accuracy of the forecast may suffer. For example, a manufacturing plant that regularly adjusts production techniques may find it challenging to create reliable forecasts due to the variability in output quality and efficiency. By focusing on these factors, organizations can significantly enhance the accuracy of their forecast, leading to better decision making and improved operational performance. Moving forward, according to Hazer and Render 2008, the forecasting processes can be classified into various categories based on its context or focus. This classification helps organizations select the most appropriate forecasting method tailored to their specific needs and objectives. Continuing with our discussion, forecasting can be broadly categorized into two types based on the nature of the data used: quantitative and qualitative forecasting. Quantitative forecasting, which is statistical forecasting, involves the use of numerical data and statistical methods to predict future outcomes. This approach relies on historical data, trends, and mathematical models to generate forecast. For instance, a retail company might analyze post sales data over several years to identify seasonal trends and patterns, using this information to project future sales for upcoming seasons. Quantitative forecasting is particularly effective in situations where sufficient historical data is available, as it allows for the application of various statistical techniques such as regression analysis or time series analysis to yield precise and data driven predictions. Qualitative forecasting, subjective estimation, on the other hand, relies on expert judgment, intuition, and subjective assessments to make predictions, especially in situations where historical data is scarce or non existent. This method is often used in new product launches, market research, or scenarios impacted by the human behavior. For example, a company planning to introduce a new product may conduct focus groups or surveys to gather insights from potential customers about their preferences and expectations. These insights would then inform the forecast for demand, considering factors that may not be quantifiable, such as consumer sentiment or market trends. Qualitative forecasting is valuable in complex or rapidly changing environments where statistical methods may not capture the nuances of human behavior or market dynamics effectively. Furthermore, let's categorize forecasting based on the time frame, which includes short range, medium range, and long range forecast. Short term forecasts typically cover periods of up to 1 year and are often used for operational planning, such as inventory management and production scheduling. Medium term forecasts, ranging from 1 to 3 years, are valuable for strategic planning, enabling organizations to align resources and capabilities with anticipated market trends. Long term forecasts extend beyond 3 years and are primarily used for high level strategic decisions such as capital investments and product development. Moreover, the forecasting processes can be classified into three types based on methodology: time series methods, causal methods, and predictive methods. Time series methods involve analyzing historical data points collected at regular intervals to identify patterns or trends over time. This approach assumes that the past behavior will continue into the future, making it effective for predicting short term outcomes. For example, a clothing retailer might use time series forecasting to analyze monthly sales data over several years to predict future sales during the upcoming holiday season. Techniques like moving averages and exponential smoothing are commonly used in time series methods to generate forecast based on observed patterns. Causal methods focus on identifying relationships between the variable of interest and one or more independent variables that influence it. This approach seeks to establish a cause and effect relationship to make predictions. For instance, a fast food chain might analyze the impact of advertising expenditures on sales revenue by examining past data to determine how changes in marketing spend correlate with changes in sales. Causal methods often utilize regression analysis to quantify these relationships, allowing businesses to forecast future sales based on anticipated changes in advertising or other influencing factors. Predictive methods, also termed as qualitative methods, utilize expert judgment, insights, and subjective assessments to forecast future outcomes, particularly in situations where historical data is limited or unavailable. This approach is especially useful in new product development or when predicting market trends. For example, a tech company launching a groundbreaking gadget may conduct focus groups and expert interviews to gather insights about consumer preferences and market potential. These qualitative inputs help inform the demand forecast for the new product, capturing insights that quantitative data alone might miss. Hence, we can say that the classification of the forecasting process can be understood through the context of available data and the nature of the products being forecasted. When forecasting for an existing product, historical data is typically available, allowing businesses to apply statistical methods such as time series analysis or response surface methodology. Time series methods leverage past data points to identify trends and patterns, facilitating accurate predictions of future demands based on historical performance. For example, a beverage company might analyze sales data for previous years to forecast demand for a seasonal product. Data is available, qualitative methods come into play. These methods rely on opinion based data that encompasses qualitative descriptions such as good, bad, or acceptable, allowing organizations to gauge potential consumer perceptions and preferences. In some cases, expert opinions or panel comments are solicited to enrich the qualitative data pool, providing insights that can guide forecasting efforts. The blend of qualitative and quantitative approaches ensures a more comprehensive understanding of market dynamics, catering to the specific forecast needs of different products and contexts. Therefore, the classification of the forecasting process also considers the time horizon over which predictions need to be made, as different variables of interest can exhibit varying levels of volatility and stability. For instance, certain elements such as housing development or the long term effects of the global warming require forecasts that extend over extended time ranges. These long range forecasts often rely on methodologies that account for broader trends and systematic changes in the economy, society, or environment. Conversely, for shorter periods, parameters such as fuel prices, material availability, and labor availability must be predicted with a more immediate focus. Short term forecasting typically utilizes different methodologies, often emphasizing current market conditions, trends, and seasonal variations. The choice of methodology varies depending on the situations at hand, allowing organizations to select the most suitable forecasting techniques that align with the time frame and the nature of variables being analyzed. This adaptability in forecasting methods ensures that the businesses can make informed decisions based on the specific temporal context and dynamics of the factors affecting their operations. In this session, we have learnt about process of forecasting. We have learned various types of forecasting methodologies. That's all for today. Thank you. Happy learning.